Audio Jungle. Audio Jungle.
Here we'll see that the relations for different circuit elements, as I mentioned, even here basic circuit elements. First I am giving for what resistance. Just before we mentioned that definition for resistance, and again we are writing voltage, current, power, energy relations. First when I write for the word voltage, what is the basic definition for voltage? Voltage, or even you can call it as what, a potential difference. Okay, what is the basic definition for the voltage? Voltage is nothing but just before when we write that resistance like a device, for this resistance, when I am applying the what, voltage, what is this voltage? And we'll be indicating every time that is one larger line and another one is small line. What that indicates? One is indicating that is high potential, other one is indicating what, low potential. Okay, so that is the meaning for what voltage or potential difference. It is not compulsory that high potential means always like a 10 volts, 5 volts, and low potential must be what, 0 volts, like that. It could be what 10 volts, and here other one, like you can have 3, 4, 5, 6 different kind of volts, even up to 9.99 like this. So because of the difference only some energy is what applied here. So whenever there is a potential difference, okay, then only charge transfer takes place. Got the point? So from this we are writing the what, definition. What is that voltage? Voltage is nothing but the amount of energy required in bringing the what, unit charge from infinite distance to the what, specified point. Got the point? How we are defining? Voltage is nothing but the amount of energy required in bringing the unit charge from infinite distance to the specified point. So how I can write this definition in the form of mathematical form, that is V is equal to, okay, energy we are saying, so I am writing in the form like dW by unit charge, means I am writing dW by dQ. This is the what, basic one. So what is the standard units we are giving? Voltage means units we are giving volts, but at the same time we can even give another unit based on this standard definition. Energy means you can have, that is what, joules. Charge means coulombs. Joules per coulomb or volts, both are same, equivalent to each other. Now by Ohm's law, what we can write from here? Based on our Ohm's law, voltage is nothing but V is equal to I into R. This is one of the different form of what, Ohm's law you can say, and this is the what, basic definition. Next, when I go with current, right? Current we are indicating with what, I, intensity of electricity, or current we are saying. We already indicated the statement for what, current. What is that current? It is the rate of flow of charge or electrons. So how I can give that mathematical relation? I is equal to dq by dt. So when we write the what, units, that coulombs per second, or the basic unit we are writing it as amperes. But by using Ohm's law, what is the current relation? That is I is equal to V by R we can have. This is another form of what, Ohm's law. But at the same time you can even replace that I is equal to what, dq by dt, that I can write even what, R into dq by dt also. Okay, this one is also useful. Means all these are what, different form of what, Ohm's law. to express, and we can even use this relation in finding another quantity. Now we'll see another relations for resistance. Another relations means like power as well as what energy. What is the basic definition for power, right? How we give that? The rate of work done or energy. Means rate means every time we follow with differentiation. So how we express the relation here? Rate of work done means dW by dt. This relation we can even write it as dW by dq as well as dq by dt. Absolutely there is no change. Again you can cancel dq dq, same relation we will get. So dW by dq means we can write it as voltage. Dq by dt means we can write it as what? Current. So power, that is rate of work done or energy, you can even express it as what? Product of voltage and current. When we follow with Ohm's law, by Ohm's law what we can write? P is equal to I square into R. When I replace that current in terms of voltage, we can even write it as V square by R. Any one of these we can use it for the what? Power dissipation by the what? Resistance. What are the units for power? Watts. If you follow with this, you can even give it as what? Joules per second. Watts are joules per second, you can indicate. Next one, what will be the energy expression or energy dissipated by this? Energy we can indicate with ERW, right? Power is what? Rate of work done or energy. Just opposite action to get the what? Energy. How we give that? Energy is nothing but capacity to do the work is nothing but what? Energy. So what is the opposite action for this? Means we follow with what? Integration. ERW we are indicating with what? Integral PDT. Integral PDT means power, you can even express it as what? Product of voltage and current, then we get V into I into dt. When I follow with this Ohm's law, how we can write this relation? Integral V square by R into dt I can write, or integral I square into R dt I can write. These are the expressions we can use it for what? Energy calculation. Units are joules. So these are the what? Basic voltage, current, power, energy relations based on Ohm's law we are using, right? And we use these relations for calculating what? Unknown quantity. Here in this session we are going to discuss about next basic circuit element, that is inductor, and how it is having that property inductance here, right? So when you just consider the word conductor, when you go with some number of turns, when you go with the winding process, then automatically we name it as a what? Conductor becomes what? Coil or inductor, and it exhibits the property of what? Inductance. Got the point? So whenever conductor is wounded with some number of turns, then it becomes a what? Coil or inductor. Got the point? So I am just going with some number of turns, then automatically we can name it as what? We can name it as coil or inductor, and it exhibits the property of inductance. So how it is exhibiting? Whenever you give the word time varying current, how you can give the current? When you apply the word voltage across these terminals, then automatically current will be flowing through it. So when a time varying current is flowing through this coil or inductor, again a time varying magnetic flux will be induced in it. Then what will be the total flux? Okay, total flux I am indicating with xi. Xi is also what? Time varying. It is proportional to time varying current. So when you remove the word proportionality, we are introducing what? Proportional constant. Got the point? So xi of t is equal to L into I of t, where L is the word inductance, or where L is the word inductance or proportional constant. It is the just a property of coil or inductor. Okay, how it is related to our Ohm's law? Only the difference is what there we are giving in between voltage and current. But when it comes to the what coil or inductor, we are dealing with the what flux and the what current. Got the point? So time varying flux is directly proportional to the what current flowing through it, but it is only possible when temperature is what kept constant. Got the point? When temperature is kept constant. And then how we are going to write the word other relations? What are the other relations? As we already seen that voltage, current, power, energy relations for the resistor, means that property resistance. Similar fashion here we are going to write relations for voltage, current, power, energy relation for inductance part. How to write with that? As we identified, this is a relation for coil or inductor. Okay, that is a flux directly proportional to the current flowing through the coil. But it is possible only when temperature is kept constant. What is another behavior according to our Faraday's law of electromagnetic induction? What we just given here, just before we talk about when a time varying current is flowing through the coil, automatically a time varying magnetic flux will be induced, we are saying. According to that, when you go with induction process, automatically all these are based on what the Faraday's law of electromagnetic induction. Just we are writing a relations for this element based on the electromagnetic induction. What is that? Whatever the amount of EMF induced in the coil or inductor is directly proportional to rate of change of flux. Got the point? How it is related you will be observing here. So what we are saying, according to Faraday's law of electromagnetic induction, I am just writing here by Faraday's law of electromagnetic induction. What we are saying, EMF induced in the what? Coil or inductor is directly proportional to or is equal to, we are saying, rate of change of flux. But there is a difference, okay, in indicating this relation. Some people denote with what negative sign, some people will be added with what positive. But actual sense, flux is a word time varying, means alternative in nature. Positive will be there, negative will be there. So it is just in the form of like a sinusoidal waveform if you consider that basic waveform. But always our standard textbooks indicated only this negative sign. Again, to compensate the negative sign, what we are saying, we are going with what? Lenz law. By Lenz law, what we can say? What is Lenz law? Voltage is the opposition for the cause EMF, means voltage and EMF both are out of phase, so you can indicate with negative sign with this. When I write that voltage is equal to minus of induced EMF, I can write. So to compensate the negative sign, we are again following with Lenz law also. Otherwise, if you just indicate with plus or minus, absolutely no need to again follow with this Lenz law procedure. But when I say only negative sign, then you follow with this. Now what we can write? What will be the voltage across the coil? Voltage across the coil or inductor. Okay, we are talking about property of inductor or coil, that is inductance, but we are just discussing about inductor or coil only. So what is the voltage across the coil or inductor? Minus or minus you can cancel and you can write d by dt of. What is the flux here? Flux we indicate it is a time varying flux which is represented in what? L into I of t. But L is just a what? Proportional constant. constant differentiation is what? 0. It is just in the form of d by dt of u into v. So when I expand u into, that is u dash into v plus v dash into u, like that you can follow with basic differentiation. But dl by dt becomes 0 because L is a proportion constant. So what will be the relation we get? Voltage across the inductor, we can write it as what? L into di of t by dt. This is the voltage across the coil or inductor. You can write in terms of like volts. Now coming to the next parameter, as I mentioned earlier, we are just writing voltage, current, power, energy relations. We just did for the voltage part. Now what will be the current expression, right? Look at this expression here. What is that? Voltage expressed in terms of the what? Current with the differentiation process. How to get the current? You need to do opposite action. What is opposite action for differentiation? That is what? Integration. Do that, then automatically we can write current through the inductor. What is the current through the inductor? I of t is equal to, we get 1 by L integral v of t dt. So limits, definitely time varying means limits will be there. So when I just indicate time instant with t, previous what will be the limit? I am considering with what? Negative infinity to next instant what? T, because time is an independent parameter. Time is changing like from what? Minus infinity to plus infinity. So time t, so we are indicating. So previous limit I am considering what? Minus infinity. Next instant is what? T. That is the reason why I represented the word integration limits with minus infinity to t. And what are the units I am writing? Amperes. Just opposite relation for this differentiation, we got the word current. Now after voltage current, what will be the power relation? Power means you can write a product of voltage and current. Any one of these you can replace, okay, right? Already voltage expression you have, that is when I write, entire power expression will be in terms of the what? Current only, right? I am expressing voltage also in terms of the what? Current. Then what will be the relation we get? L I of t into di by dt we will get. Got the point? This is the power expression for the what? Inductor. You can write units as a watts. Now we are going to write energy relation. Definitely inductor is a what? Storage element. Understood? Inductor is a storage element. So what will be the energy? You can indicate W or E for this. So how to find energy? How to find energy here? Just if you follow with this power, okay, energy nothing but what? Capacity to do the work. When you write for power, we are writing differentiation of that rate of work done or energy. You are writing it as what? Power. Opposite action for this will give the what? Energy. That we are writing it as what? Integral pdt. So when you write integral pdt, what will be the result we get? Integral Li of t into di by dt. Again we are doing the integration with respect to time. Simplify this. When you simplify, automatically dt will get cancelled. X dx means you can write x square by dx. With that relation we get what? Of Li of t square. This is what? Energy stored by the what? Inductor. Okay. With respect to instantaneous one we are writing, okay, right? So now if you just observe all these relations, what are the relations here? Voltage, current. Look at this voltage across the what? Coil or inductor we are writing. This is what? Current. This is power. And this is what? Energy stored by the what? Inductor we are saying. When you just look at the basic circuit elements, resistance, inductance, capacitance, right? Out of these three elements, resistor is just a what? Passive element that we already given. Okay, but when it comes to the what, both inductor and capacitor, both are what, passive, but having that storage ability. But it is only a temporary process, not like a permanent. These are just having some storage capacity. One more relation, if you notice, what is that? If you just observe this flux and the what, inductor current, both are proportional to each other. Relation is similar to y is equal to mx. Earlier when we write relation or the what characteristics for the what resistance, we had seen that relation V is equal to I into R. Similar relation is there. So when you draw the VI characteristics, so what will be the way we get characteristics here? How we get characteristics? We are indicating flux with what, y-axis, current is along with what, x-axis, then it is similar to y is equal to mx. We get what, straight line passing through origin. Similar to that what, even resistance. Slope of this straight line indicate what, our inductance or what, proportional constant only. So these are the relations, but all these are valid only when temperature is what, kept constant. Next we will look into the another circuit element. Next basic element is capacitor here. Now when we go with conductor exhibit the what, property like a resistance we had seen, and we are making a resistor. Next one is what, when you wind the what, some number of turns for the what conductor, it becomes a what, coil we had seen. Now for the capacitor we are just observing the what, two conductors or two plates or two metals, like you can even name it as like a parallel plates. Two conductors we are considering here, right, separated with some distance, right. Then we are naming it as what, capacitor, and it exhibits the what, property of what, capacitance. It can acquire the what, some amount of charge, okay, in the form of what, field. So how you are giving energy for this? So when you just apply the what, energy in the form of like voltage we are giving for this VRT, then current will be flowing through it. But capacitor only allows the what, alternative current. Okay, so DC current it is not accepting, so it works only for the what, AC current you can say, but it is in the what, steady state portion. Okay, right, time varying when time is what, changing. Got the point? Like initial state, steady state, that complete behavior we are observing in that special topic, that is what, transient behavior. But at this moment we are just only focusing on what is steady state behavior, and mainly we are writing the what, voltage, current, power, energy relations for the what, all these basic three elements such as resistance, inductance and what, capacitance. Got the point? So when voltage is applied, automatically this plate or the what, metal is associated with this high potential, we are indicating with what, positive sign. Another one we are indicating with negative sign, that is what, for the what, low potential. Okay, so because of this external energy, automatically charge will be acquired by these plates. Due to this, field will be created. Okay, right, electric field will be created. So what we can say, capacitor can store the what, energy in terms of the what, electrostatic field. Now if you just write the basic relations, what will be the charge acquired by these plates or the capacitor? Charge acquired by the capacitor is directly proportional to what, based on your applied voltage V of t. Okay, this is the basic relation. Similar to our flux linkage is proportional to current flowing through the coil inductor, here charge acquired by the capacitor is directly proportional to applied voltage. Similar behavior. Okay, but all these are valid only when temperature is what kept constant. That is the way we are imposing our Ohm's law into these two elements, that is what inductance and what capacitance. When you remove this proportionality, what will be the relation we get? Q of t is equal to C into V of t, where C is the what proportional constant or capacitance. Okay, where C is what capacitance or proportional constant. It is just a constant, only charge and the what voltage, these are what time varying quantities. Again relation, if you just notice, relation is similar to again y is equal to mx kind of category. So once you draw that characteristics, resistor means voltage current, inductor means flux current, now capacitor means charge and the what voltage. So we are just giving QV characteristics. Okay, if you draw the QV characteristics, Q along with y-axis, that is charge, voltage is along with x-axis. So what will be the way we get that characteristics? That is a straight line passing through origin. Just I am drawing thick line to draw your attention. That is a thick line, that is a straight line passing through origin. So what will be the slope here? Slope indicate our capacitance or what proportional constant. Now after having this basic relation, as I said, when we give the word time varying voltage, then charge will be acquired by this again in the time varying fashion. Okay, that we given. Okay, this is a basic mathematical relation. Now if you just identify that current voltage power energy relations, what will be the current basic relation? Current, if you write, what will be the current passing through the capacitor I of t? Current is what? Rate of flow of charge. Rate means differentiation, that is dq by dt we write. So if you just replace the word charge here, what we get? What will be the current? I of t is equal to d by dt of what is the charge here? Use this relation C into V of t, similar to d by dt of uv function. If you expand this, again charge is a constant, differentiation becomes 0. What will be the current? I of t is equal to, we get C into only dv by dt we will get, because dc by dt becomes what? 0. This is what? Current through the capacitor. Again just after having this relation C into dv by dt, we want to even have what? Voltage. Observe here, differentiation is indicated for voltage, that is related to current. If you just do the opposite action, what will be the voltage across the capacitor? Voltage across the capacitor, right? V of t is equal to, opposite action means we do integration, 1 by c integral I of t dt we will get. Integration means limits we are taking like minus infinity to next instant is t. As I mentioned here, time is independent, changing from minus infinity to next plus infinity, like time is independent. So we are starting from previous limit, that is minus infinity to next instant is what? T. It is in terms of volts. Here current is in terms of amperes. Okay, voltage expressions. Got the point? Now power expression, if you write power, P of t is equal to V of t into I of t. Take this product, you can indicate with any one of these. Now I want to replace the current with this expression, then how we get the power relation? Okay, already voltage is there, so C into V of t into dv by dt we will get. This is the power expression for the what? Capacitor. We are expressing in terms of watts. Next expression is what? Energy. How to write energy? E or W you can indicate. EC of t I am writing. Just follow with us. integration of the power gives what energy or work done. Integral p dt. Follow with the same procedure how we did in the case of what inductor, right? So if you do that integration, what we get, c into v of t into dv by dt. Okay, so that we are doing integration with respect to dt will get cancelled. Again x dx concept, x square by 2 will get. So what will be the expression we get when you simplify here? Energy stored by the capacitor means like we get half c v of t square joules we get. Okay, so look at these basic relations for this capacitor. Current through the capacitor, voltage across the capacitor, power expression related to the capacitor, and this is what energy stored by the capacitor, that is half Cp square. When you compare with inductor, half Li square. Okay, but there is no energy stored by the what resistance. Resistor just dissipate what energy in the form of heat, but only both inductor and capacitor stores energy. Okay, inductor stores energy in terms of the what flux in magnetic field, whereas capacitor stores energy in terms of the charge in electrostatic field. Okay, next we just write all these voltage, current, power, energy relation and we compare. Okay, what will be the difference among these three elements. Now we'll see the relations among these three elements: resistance, inductance, capacitance, right? Ohm's law is applicable for all these, but what will be the major limitation here? Temperature is kept constant, then only all these are valid. Okay, so these are the relations we had given for resistance, right? Voltage, current, power, energy, but this will be the amount of heat dissipated. Okay, right? So resistor is just only dissipating energy in the form of heat only. How we indicated resistance here? In this fashion. So if you give voltage in this way, this will be the word current direction, but you can even give the word current or the word voltage in opposite manner also. Absolutely there is no change in our behavior. So by this reason what we name that resistance, it is a bilateral element. Basically resistance is a passive, and the what characteristics are what means Vi characteristics seems to be like y is equal to mxc form, so straight line passing to origin, so it is a linear element. So passive, linear element, even bilateral element, but it is dissipating energy in the form of heat. This is the what major relations for resistance part. When you go with inductance and capacitance, both are what means inductor, capacitor, if you see, both are storage elements, right? These are what stored energies. Okay, these are stored energies among these means in between inductor and capacitor. This is the amount of energy stored by the inductor, this is the what energy stored by the capacitor. Okay, both are passive only, but can have the what storage ability. How the inductor is storing? Inductor stores energy in terms of the flux in magnetic field. Okay, capacitor stores energy in terms of charge in electrostatic field. That is the difference among these. Okay, when you just look at the expressions, okay, differentiation is there for the what inductor voltage, whereas if you see that capacitor, differentiation is there for the what current to the capacitor. But if you go with integrations, inductor current is having that relation, here capacitor voltage is having that relation. So when you just observe this expression, what is the meaning of this inductor current? Okay, minus infinity to t. Suppose if you are just operating the what inductor in a circuit by providing a switch action at that particular instant, suppose time t equal to 0 seconds or 2 seconds, 3 seconds, whatever the time instant you want to impose. Okay, before that instant, because you are starting from minus infinity to plus infinity, if you are operating somewhere here, definitely from minus infinity to that particular instant, there will be some amount of flux will be there if it is what inductor. Even if it is capacitor, there will be some amount of charge will be there. That is the reason why inductor, capacitor both doesn't allow sudden change in current as well as voltage respectively. That is the meaning of these expressions. Are you understanding? Inductor doesn't allow sudden change. I am saying, okay, not accepting complete. Okay, overall after some time instant definitely current also changing, but sudden change is not accepted by the what? Inductor current. Capacitor also doesn't allow sudden change in what? Voltage. Because some value will be there, okay. So sudden change is not accepted by these two parameters in respect to inductor and capacitor. But there is no such property for this what resistor. Resistor allows sudden change in voltage, current, whatever you give. Just it is dissipating energy in the form of heat. But whereas inductor, capacitor, passive elements but can have the what storage ability in this way. Okay, that is the difference in between these elements when you compare with this. But similar way, how you are indicating bilateral, if you even go with inductor also, you can give the word current, voltage in either direction. Absolutely there is no problem. You can even give what for the same element. I am just using some other color to show that you can even give the word voltage, current in this fashion. Absolutely no difference. Even for capacitor also, if I give the word voltage, then current will be in the direction. But if I change the word current direction, even voltage polarities will be different. Okay, this will be the thing. Means all these three elements are what? Linear bilateral passive elements. But both inductor, capacitor are what? Storage elements. Even respect to units also we indicated for all the parameters in this session. Okay, right?